All right. Part of the reason why I don't mind reviewing is because it's been a long 3 days, and I'm sure some of you haven't put much thought here. But again, the rules are the next test should be super easy.
Yeah, it should be.
All right, because all it is about knowing the rules. All right. So for us, multiplying 10 times -2 is -20. Then you just look at the variables. If there's not an exponent, remember it's a 1. And then the rule is you add exponents. So x cubed times x is x to the 4th. Y times y to the 5th is y to the 6th. And z squared times z is z to the 3rd power. All right. So those are the basic rules for multiplication. All right. Now we had something which was called a power to a power. All right. So a quick little review. 4 cubed is 64.
Yes.
You come in interrupting. Are you not doing that?
Yes, sir.
All right. Now we say power to a power. The rule is multiplying. So you would say 64x to the 6th, and then b to the 1st cubed is b cubed. All right. You with me on that? So those are the rules. All right, now let's jump down here. Something probably as hard as you will see is something in this respect. You want to square -3, which becomes a 9. Power to power, you multiply. 2 cubed is 8. Multiply exponents. Multiply numbers now. Add exponents. Yep, that's all there was. All right, anybody have any issues? All right, that's a nice little review. All right, nice little review. All right, now let's go just check out 7-2. All right, where we did some division. All right, so we said multiplication, you add exponents. So division, you probably what? Subtract exponents. So if you're looking at number 2 real quick, we're just saying that's m squared. Come on, guys. I'm not playing. All right. I don't want anybody messing around. I want you to sit there. All right. Just be patient. All right. Let's go through a couple of problems. And then today we'll have something else. All right. Very easy. All right. Now, again, if we were asked to do something like question number 6, we're reducing the numbers just like a normal fraction. So 2/14 is the same as -1/7. And then there would be a y7 and y5 creates y second on the top. All right, that's it. All right, what?
If it's like y5 on the top and y7 on the bottom, would the y2 be on the bottom?
Of course.
Okay, thank you.
All right, now, what?
I don't know. You can use numbers or just with more.
What?
I don't know how you would do number 8.
Yeah, we're doing number 8 right now. All right. What?
So like, is that the answer or?
What if it, do I normally write the wrong answer up there, or what are you asking me? Is that the right answer? Shh.
Y squared over 7.
Yes.
Is it?
What do you want me to say to that? That's what I said the answer was. Shh. All right, now on number 8, again, just because there's a fraction, all right, you just have to understand that the cube affects everything. All right. However, I did tell the kids that it's better to simplify first. All right. So what does that mean? There's a 2, a squared and a cancels 2 and a, and then b, and then to the 3rd power. All right. So if you can simplify, you should. And now this is just 2 cubed, which is 8, a cubed, b cubed. All right.
How they cancel out.
I don't know what you mean.
You're saying they cancel out?
A squared divided by a is what, Oliver?
A
Okay.
squared.
A squared divided by a is what? A, you're right, a. You're subtracting the exponents, Oliver.
Oh, because
2, shh. 2 minus 1. That's it. All right, now for number 10. Just quickly. No, I cannot. All right. I am simplifying. All right. 2 and a 1. There's nothing to simplify. R to the 5th, R to the 4th leaves me an R. And the W cubes cancel. So literally all I'm dealing with is 2R to the 4th power. Sorry, my eraser is so big. So it's going to be 2R to the 4th power. So everybody agree with that?
16.
Yes. And then of course, 2 to the 4th is 16R to the 4th. Right? Now, the other nice thing is, let's take a quick look at 16. Negative exponents. Now you shouldn't have to find the rules. The rules should already be on your paper. So I'm just repeating what's already on your paper. All right, and we said when you have a negative exponent, they just change. If it's in the numerator, it goes in the, if it's in the denominator, it goes in the. So my advice here is to rewrite this as b to the 5th over b to the 4th.
Which is just B.
Which is just b. All right, negative exponents. All right, now let's take another quick look at maybe something like number 22. All of this has a negative exponent. So all of that moves up. So that's going to be m squared t cubed to the 1st power.
Why is it M squared?
Oliver, does it have a negative exponent?
No. And it's going on top of M, so why is it?
Asking you about the highlighted m squared t cubed.
Okay,
Does it have a negative exponent?
Yes.
So it has a negative exponent, so you move it.
yes.
Now, everything in the top, all right, all of the information on the top has negative exponents. So all of those must move to the bottom. So that's m cubed and t to the 5th. All right, now really, does something to the 1st power really change anything?
No.
So you can just kind of drop that out. All right. Now, again, how many m's are on the top and how many on the bottom? So there's 1 left at the bottom. There's 3 t's at the top, 5 t's in the bottom. So we're left with 2 on the bottom. All right, if there is nothing in the numerator, it's like the fraction 2/4. 2/4, 1 is the numerator. All right, 1 is the numerator. What? Shh, go ahead.
Like 16.
I'm not on 16. What else?
When you
Nope, I'm not on 16. What? Oliver,
M squared. Because if you're doing,
Oliver, please, please, come on. All right, I have a whole lot of work today. I can't answer every question on every problem that you have. You have to pay attention. You know we're subtracting m squared and m cubed. 3 minus 2 today is 1. That's why there's an m on the bottom. 5 minus 3 is 2. That's why there's a 2 on the bottom.
negative, you just have to flip it.
All right. Now, Tyler, what?
I thought that we added the.
It doesn't matter about your thoughts. All right. It doesn't matter. If you're wrong, if you have something different, your thoughts are wrong. That's how it works. I'm not changing my solution for you because you thought something else. That's what I'm trying to tell you. I promise I'm right. These are the rules. I follow the rules. All right. Did you want me to go to a different problem?
Last week we did, when after we flipped them, we added.
Not last week we did. No. Tell me what problem you're referring to.
On 16.
All right. So let's look at 16 and see where you're mistaken. We just did that.
I would add. Yes.
What are you talking about? Shh, shh. They're both negative exponents, so I switched them.
Yeah. Added them.
You may have added them. I didn't. b to the fifth and b to the fourth reduces to b to the first. Correct? It's not b to the ninth. B to the ninth would be b to the fifth times b to the fourth. All right, one more last little bit of help. Maybe if I can find something. All right, 38. Everybody looking at 38. I want everybody to understand 4 to the negative 4 is 1 over 4 to the fourth. All right. I know it's 1 over 256. I don't really care that you know that 4 to the fourth is 256. I care that you understand that because we have a negative exponent, I move it. All right, now look at 40, just to double check. Everything is to the negative 2. So I'd like everybody to just say that's the same as 3/5 squared.
Oh, yeah.
And that's just 9 over 25. All right. If you left it as 3 squared and 5 squared, I wouldn't object, but simple numbers, we normally just go ahead and work out. What? Yes. Look at 42 for a second. All right. Look at 42. H to the negative 6. That needs to be moved up. So it'd be h cubed times h to the 6, which is h to the 9.
Over 1.
All right. Anybody have any questions with that being h to the 9th? Anybody? All right, look at 44. This has a negative exponent. This has a negative exponent. Those things need to move. So that would be m cubed over k. If you want to put first, you can. And then it would be L to the 6th. And now lastly, I haven't mentioned this, but anything to the 0 power is what?
1.
Everything here is to the 0 power. Therefore, it equals what? 1. All right. And now let's go up for, are you asking me about 24, Nora? Okay. Now, once again, all right, here's what my suggestion is. This whole thing is to a negative 3. So I'm going to move that whole thing. So that whole thing's going in the denominator as negative 2 mn squared to the 3rd power. 4 stays on the bottom. M to the 6th goes on the top, and n to the 4th on the bottom. This is a very good problem. Anybody have any questions with that so far?
Wait, is that it?
Now we have to cube what's inside the parentheses. Negative 2 cubed is negative 8. M cubed n to the 6th. Now I'm going to multiply that by 4n to the 4th. Bless you. Now again, I'm just going to simplify the bottom part. Negative 8 times 4 is negative 32. Now, for me, how many m's are on the top?
6.
And how many are on the bottom?
3.
So that leaves me with 3 on the top. Hey, listen, seriously, if you need to move, just go ahead and move. All right, you're playing around for some reason today. And then finally, I have how many n's in the bottom? 10. To me, that's the process. All right, that's the process. Now, 26. 9 to the 12th, 9 to the 8th. That's just 9 to the 4th. Here, r cubes do what? Right? No, it's not.
1
No,
over
1 over
2.
2.
1 over t squared. All right. Come on, Wilson. Look, you guys, for some reason, you think it's like cute day or something. All right. I'm not interested in that. I'm working. You're playing. 30. 9 divided by 3. 3. 7 on top, 6 on the bottom leaves me with
3D, just 3D.
just 3D. All right. All right, I'm pretty happy with that. So that should have gotten you caught up, okay? I think. Now, like I said, just there's videos, all right, explanations. If you're having some more trouble, you can ask me some more tomorrow. All right, let me pause the video. All right, and then what I'm going to do is pass out. Okay, so basically, you are supposed to know what a polynomial is with regards to algebra. So a polynomial is something that has exponents as whole numbers. All right, exponents as whole numbers. All right, so in this particular case, all right, most of the time it'll be something like x cubed plus x squared plus 5x minus 3. That is considered a polynomial. All right, the reason why it's considered a polynomial is because if you look at the exponents, all of the exponents are whole numbers. All right, that's the main focus. Now, 3, we really could technically say is x to the 0 power. All right, but it's not necessary to write that. That's why some people are unsure about the constant. So it is a polynomial if all of the exponents are whole numbers. All right. Now, if you're talking about a polynomial, you just don't have to have one variable either. You can have many variables. For example, look at number 4. All right. You can have many variables. All right. But it's still considered a polynomial as long as the exponents are whole numbers. Remember, whole numbers are just 0, 1, 2, 3, 4. No fractions or no decimals. All right. Now, the other thing is what's kind of important is the degree. All right. So I'm probably not going to ask you, I don't remember if I asked you a question like this in the test because I really don't think it's that important. But the degree for this polynomial up here would be 3. It would be 3 because it's just the largest exponent. All right, it's the largest exponent. Now, that's not always the case, and let me give you an example of when it's not the case. For example, if I say x squared, y squared, all right, if I said, what's the degree of this? This would be what? The highlighted would be a degree of what?
2.
2. Now, the other highlight would have a degree of what?
2.
2. Now, because it's multiplication, all right, that is considered one term. That is considered one term. So the degree, as he just stated, would equal 4. He was correct. It would be 4. You add the exponents. All right. So terms are separated by addition and subtraction. Terms are separated by addition and subtraction. All right. Now, what do I mean by that? All right. I want everybody to take a look at monomial. Monomial just means one term. So binomial means what? 2 terms. Trinomial means 3 terms. And then after that, we generally call it a polynomial. Poly just means many terms. All right. So again, these are just definitions and it's just rules. All right. That's why I'm saying it's simple. If you know the rules, it's easy. All right. So number 1, that is called a monomial because it's one term. Then its degree, if you were paying attention, the degree is what?
0.
Thank you for listening. The degree is 0. All right. The degree is 0. All right. Any constant, the degree is 0. All right. So if I was just briefly looking at number 2, is that even a polynomial? No, it's not a polynomial. And the reason it's not a polynomial is because 2, the exponent is actually a negative 2. All right. So that is not a polynomial. Number 3. Now, for number 3, what do you think 7x minus 1x is?
6x.
6x. So simplify to 6x minus 5. All right, and this is, if I had to name this polynomial, it would be called a what? It would be called a binomial. Thank you for that. It would be called a binomial because there are two terms. All right. Now, just because I want to make sure you're paying attention, this is considered how many degree? What degree is that? Green.
6.
What degree? Nope. 1. The degree is 1. All right. Now we're looking at the constant. We already had this. So the degree of the constant is what? 0. All right. So you always take the largest degree in the polynomial. So the degree here would be what? 1. All right. The degree would be 1. And then in this case, thank you. You're correct. It would be considered a binomial.
Wait, is there one when there's like a variable?
Okay, let's just do some more practice. All right, number 5. Is number 5 a polynomial?
No.
No, it's not a polynomial because there's a variable in the denominator. So it'd have a negative exponent. So it is not a polynomial. All right. If let's say it was 4y squared plus 5y minus 8. If it was that, that would be called a what type of polynomial? Trinomial, because there are 3 terms. The degree of the first term is what? The degree of the first term is 2. The degree of the second term is, and the degree of the third term is 0. So the degree of that trinomial would be 2. All right. The degree of the trinomial would be 2. All right. Those are just information. All right. That's just information. That's why it's not such a big deal. What do you need, Austin? What? What? Nothing. No, it doesn't matter to me. You raise your hand, you say, hey, help me out a little bit. Not point over there and interrupt my class. All right, now I understand the confusion. So I'm going to go down. All right. Now I'm going to look at number 7. Number 7 is called what? What kind of polynomial? It's called a trinomial. What's the degree? 5. The degree here is 3. The degree here is 5. The degree here is 2. So we take the largest one, which is a 5. All right, that would be the degree. Now, standard form. So everybody has the same answer. Standard form is basically just written in descending order. The exponents go from the largest to the what? Smallest. All right, so if I was going to write this in standard form, and this is the important part out of everything, is being able to write in standard form. You would say that's x to the 5th plus x cubed minus x squared. And I would like to make sure everybody understands the degree here is 5. All right. What?
How do you know like what sign to put if you have to like really import it?
Because the sign in front is the sign of the monomial. This right here is a positive. This right here is a positive. This right here is a negative. All right, that's it. What? Shh.
You get 5 for the degree.
The largest exponent.
So you said it was a trinomial, but couldn't you simplify?
No, you cannot simplify. You cannot add x to the 5th with x cubed. You can multiply them. Remember now, please listen, again, this is kind of one of the most important things. The number in front tells you how many of these you have. I have 1 x to the 5th. The only thing I can add to x to the 5th is what? X to the 5th. The only thing I can add to x cubes are x cubes. That's the whole nature of this lesson. All right, you will not be confused. After today, you can multiply, divide, add, and subtract. All right. Come on, Nora, what?
Isn't the greatest choice like greatest choice what's it called? Exponent? Or
That's
is it
what I
like
said. That's what I said. Exponents, exponents. Listen today. Number 9. Let's find number 9. All right. What is this called? Trinomial. What's the degree? 8. Now write it in standard form. Standard form, the largest to the smallest. So everybody should have 2x to the 8th minus 3x to the 6th minus x to the 5th. That's all there is to it. I'd like everybody to say that is obviously a trinomial and the degree is 8, and that is written in standard form. All right, so now I'm looking at number 11. This is called a polynomial. That's right, it's called a polynomial. Come on, Oliver, what?
Polynomials.
They are polynomials. They are specific polynomials. That's why I'm asking you to pay attention. You are brilliant. 3 terms is trinomial. 2 terms is a binomial. 1 term is a monomial. If there's more than 3 terms, it's called a polynomial. That's what's supposed, I don't care what you thought. Write that down. Then you should know. All right, now, writing it in standard form. Largest exponent goes first. 5x to the 4th minus x squared plus 3x minus 2. That's how simple. What?
If they both don't have an exponent,
If they both don't have an exponent, let's just do the problems on the paper. There's lots of problems on the paper. Don't try to think about all the what ifs. All right? Come on, what?
I thought.
No, what is the question? It is a polynomial because these are terms in all of the exponents are whole numbers. All right, that's why it's considered a polynomial.
Agreed.
Why don't you tell me what the degree is? All right, 13. Now we're down to good business. All right, this is what everybody knows, but we've always been adding x's or numbers. Now we have all types of things that you're going to be adding and subtracting. So everybody should look at 13 without hesitating and say that is just 7a minus 1. Anybody have trouble with 13? That's what I said, plus 1. All right, minus 1 for everybody. All right, here we go. Now, everybody's taking a look at 15. Combining like terms. Combining like terms. 6xy plus 4xy is 10xy. Now, again, combining terms. 2y is next. Plus 2y. And then after that, we're going to say 6x minus 1x is positive 5x. Can we put any of those things together? No. 10xy is different than 2y. 2y is different than 5x. 5x is different than 10xy. You can't combine them unless they are exactly the same. So here we go with 17. 3p squared plus p squared is what? 4p squared. Negative 2p minus 7p is?
Negative 9p.
Negative 9p. And then 3 plus 7. Positive 10. That's all I need for you to understand. What? Come on.
On this one, why would you add the exponents?
Yeah, that's fine.
What?
Why would you add the exponents? Would it be?
Am I multiplying?
Oh.
No, I'm not multiplying. You add exponents when you are what? Multiplying. What am I doing here? You're adding. It makes sense to me. 3p squared plus 1p squared. I end up with what? 4p squares. Remember, the number in front is telling you how many of what's behind it there are. That's what we're doing. All right, now, number 19, we start into subtraction. So here's my advice. Subtraction means distributing a negative 1. you are actually distributing a -1. Rather than distributing a -1, what I tell kids is, do this, please, look up. I would want you to say, hey, the minus sign becomes a plus sign. This minus becomes a plus. This plus becomes a minus. This minus becomes a plus. That's what happens when you distribute a negative. All the signs change. Distributing a negative changes all the signs. Notice I didn't change the numbers in front. I changed the numbers behind the minus sign. Now I'm combining terms. Is there anything I can add to 6p squared? No, thank you. 6p squared. Because I'm writing in descending order. Now I'm up for the p's. So I have how many p's left? 8. Now I'm combining the r's. No.
Negative 11.
-11r. And then the constant. There you have it. That's it. Combine like terms. Distribute your negative. All right. So here we go. Again, I like to make sure that you are seeing it properly. Distributing a negative. Notice what I do. Positive and circle. Negative, circle. Negative, circle, plus. That way I know I have changed the signs. The biggest mistake kids make is on the signs. All right, so now we're combining terms. What happens to 3x squared and negative 3x squared? They cancel. Negative 2x and negative 5x. Negative 7x plus 1. That's all there is to it. It's really simple. All right, distributing a negative again. Again, I'm cautioning you. I like to change it and circle. Change it and circle. And that way I've seen that I've distributed negative properly. So how many H's do I end up with? 9 H's. My J's become what kind? -1J. And my K's? Positive 2K. Shh. Yeah, remember, we're not doing funny jokes. All right, anybody have any questions with 23? Okay, now here we go. Determine whether each expression is a polynomial. If it is, find the degree. All right, so this, number 25, what kind of polynomial is this? It is a binomial. So everybody write down binomial. Now the hard part. What is the degree? Yes, the degree is 2. Now everybody look up here. What is the degree of 5mt? You're right, 2. All right, the reason it's 2 is because we are taking the exponents and what? Adding them. All right, the degree of this monomial is 2. The degree of this monomial is what? 2. All right. Now, you take the largest degree of the individual monomials. That is the ultimate degree. All right. So, number 27, that is called a monomial, and its degree is 0. Now, 29, we would just say not a polynomial. Not a polynomial.
I thought it would be a. Yeah, why would it?
The exponent is negative. No negative exponents. All right, here we go. Let's knock out 31. Writing in standard form. All right, Max, write that in standard form quickly.
2x to the power of 2.
Yes.
2x squared plus 3x plus 1.
You are amazing. All right, now don't be confused by the leading coefficient. The leading coefficient is 2. I'm not going to ask you about a leading coefficient. I just want you to be able to talk smart math with when you go to high school. Somebody says, what's the leading coefficient? What does it sound like? The number in front. That's what leading means. All right, that's all there is to it. All right, so Charlotte, number 33, go. Write it in standard form. What are we talking about? 10. I'm on 33.
9x.
Which variable is the largest, or the exponent that's the largest? Yeah, so you're going to write x cubed. Then what?
Plus 9x squared plus x times 2.
Beautiful. All right, Nora, next. Number 35.
3x cubed plus x squared minus x plus 2. I mean, plus 25.
That's good. I like that. All right, next. Ryan.
Yes, 5x cubed, minus 3x squared, minus x, minus 4, or plus 4.
You know, you got to look at your x, right? Do you agree? The sign in front, not the sign after. So it's
yes.
plus. Okay, next, 39. Hubbard, go. Not come on. I don't have time. You're asking is like, what's 2 plus 4? I don't know. 6x, come on.
Plus 12.
Beautiful. 6x plus 12y. Oliver, what do I have to do first with the negative?
You're gonna make it a positive, and then you're gonna circle it if you want to, and then for the 2a plus 4b, you're gonna make that plus and negative, and circle it if you want to.
Okay, now just tell me what the final answer is.
So 7a.
How is it 7?
So you're adding 5a plus 2a,
Nope,
7a,
nope.
5a, 5 plus 2 is
Look
7.
up. No, it's 3a plus, because you're distributing the negative. You're distributing the negative. Voila. All right, guys, finish up the evens for homework. Evens for homework. Yes, evens.
I just did, sir.
Any questions?
All right, let's do. Okay, now let's review negative exponents. What do I do with negative exponents? You move them. If it's in the numerator, move them to the, if it's in the denominator, move it to the numerator. So this is just 1/8 squared. I know 8 squared is 64. That's not the lesson. The lesson is, do you understand how to handle negative exponents? So on your paper somewhere, it should be negative exponents, move them. All negative exponents must be moved. If they're in the numerator, move them to the denominator. If in the denominator, move them to the numerator. That's what you're supposed to be telling me. All right. Now let's take a look here at 47. So if I pull up 47 on your paper, where does H go? On the top. Where does F go? On the bottom. Where does G go? Stays home. Exactly. That's what you're supposed to know. Come on. They're just rules. Everybody can follow rules. Everybody. All right, let's find something else maybe. Let's try 51. All right. Yes, that was the answer. I wrote it. It must be the answer. Here we go. Everybody's looking at 51. All right, tell me about 6/54. What does that reduce to? What? 1/9. 1/9. What happens to the F's? What happens to the F's? They do cancel because they're both the same. You could both move them, right? And then they would just cancel. Does everybody agree with me? F -2, F -2, cancel. Now, what do I have to do to this G to the -5? Put it on the top. And when I put it to the top, how many G's are there now? How many G's are there now? 8. Because there are already how many on top? And how many did you add? So altogether that would make 8. Come on, guys. H5 and H cubed leaves me with what? H squared, where? Where? On the top. All right, I'm pretty happy with that. All right, let's do one more and then we'll jump in.
Those were the algebra.
Oh, that's the one I said that we're algebra 2. All right.
I have a question on them.
Which one? Quick.
Can you do 23?
20.
Or 17, I guess.
Let's do 23. Anything to the 0 power is automatically what? Everything there is to the 0 power, correct? So all of it is what? 1. Now let's just look at 17. The whole top is what? 1. Do you agree with that now? Now the W to the -1 has to be what? On the top. And now everything else stays. Do you agree with that? Anybody else who looked at this? I appreciate that very much. Anybody else have a question who may have looked at this a little bit over the weekend? Try to make sure you're good. All right. Now put that
For 19, like with that 0, is it just like nothing?
right. Anything to the 0 power is 1. It's not that it's nothing, it crosses out to a 1. Okay. So now I'm going to pause for a quick. All right. So earlier in the other class, all right, we had to define what a polynomial is, what a degree is, monomial, binomial, trinomial. I bet monomial, people know that's just what? 1 term. Binomial is probably what? 2 terms. And of course, a trinomial would be what? 3 terms. All right. Now, terms are separated by addition and subtraction. Do me a favor, make sure you understand. You don't have to write it down. It kind of makes sense. Terms are separated by addition and subtraction. So I'm going to write something up on the board here. X, how many terms is that? So now if I say X, Y, how many terms is that? 1. All right. X squared or X, Y, Z, how many terms? 1. W, X, Y, Z. 1. 5. W, X, Y, Z. 1 term. That's it. It's 1 term. All right. So that all that is a monomial. Now watch this, please. How many terms? 2. That's considered a what? Binomial. All right. How many terms? 3. Trinomial. Terms are separated by addition and subtraction. After 3 terms, we just call it polynomials. All right. Poly just means many.
So 3.
All right. Polynomial means many. So you have a monomial, binomial, trinomial, and then everything else is a polynomial. Is every monomial a polynomial? Technically, yes. Every binomial is a polynomial. Every trinomial is also a polynomial or a polynomial. Now, listen, how do we define what a polynomial is? Polynomial exponents are whole numbers. Exponents are whole numbers. That's how you define it. For a polynomial, binomial, any kind of nomial, all right, you are going to look at the exponents. All right, you're going to look at the exponents. All right, so what does that mean? Everybody look at number 2. How many terms is that?
1.
For number 2. 2 terms, right? But the problem is it a polynomial? And the answer is no, because of this. Highlight this for me. The exponent is in the denominator. So technically, that's the same as 3q to the -2 plus 5. Is this a whole number? No, so it's not a polynomial. So it's not a polynomial. All right. Now, number 4 is called a what?
Those.
Trinomial. So everybody put down a trinomial. All right. Now, after you write that trinomial, I need you to understand this, please. Look. We have degrees. All right. We have degrees. Every monomial has a degree. All right. So I'm going to show you what I mean. So if I say x cubed, that degree is equal to guess what? 3. Very good. If I said x squared, the degree is going to be what? 2. If I say x, the degree is what?
1.
Good job. If I say 5, the degree is what? Follow the pattern. What's the degree? 0. Thank you. The degree is 0. Part of the reason why we say the degree is 0 is because technically you could write 5 as 5x to the 0. You with me? All right, so now pay attention. If I said x cubed plus x squared, what's the degree of x cubed? 3. What's the degree of x squared? 2. So what is the overall degree? Good job. 3. Now, why is it 3? Because you take the largest degree of the individual monomials. Come on now, stop daydreaming. You take the individual degree of each monomial, compare it, and whichever one is larger, that's the degree. All right, so now a little bit more complicated. All right, I'm gonna give you another example. If I said x squared y cubed, is that a monomial or a binomial? Monomial. Now, what's the degree?
3.
Good. It's 5.
Oh, because it's different.
Yeah, it's different. So these you have to do what to the exponents? Adam, that's the degree. All right. I'm not going to make this a big deal on your test, okay? I'm just trying to tell you, eventually somebody might ask you about the degree. The degree is the sum of the exponents. All right. So I have x squared y cubed. The degree is 5. Now I'm going to come over here and write x squared plus y cubed. What's the degree? 3. Thank you for listening. I'm going to give you a couple more examples just to make sure. Please just pay attention. Please pay attention. You don't have to write it down. Right? If I said x to the 4th, y cubed, what's the degree?
4.
7. Right? You're adding them together because it's a monomial. All right? What if I said to you x to the 5th plus x to the 4th y squared? What's the degree of this guy? 5. What's the degree of this guy? 6. What's the degree of that binomial? 6. Nope. You don't add the monomials. You add the variables in the monomial. So bear with me. All right, one more example. All right, let's say I had something wild and crazy like x cubed plus x squared y squared plus y to the 5th. What's the degree? Come on. What's the degree of this? 3.
4.
What is the degree of this? 4. What is the degree of this? So the degree is 5. Now you understand what I'm saying. I promise you it's not a big deal. It's not really going to be on the test. It's a minor detail. Minor detail. All right, but now let's go back. All right. So please, someone who's been paying attention, what is the degree of this monomial? 3. Thank you for listening. What is the degree of this monomial? 2. What is the degree of this monomial? 0. What's the degree of the trinomial? Yes. Right? It's just rules. All right. So you don't have to be smart, right? There's nothing to it. Nothing. Just following rules. That's why this was easy. All right, now I'm looking at number 6. What's the degree of this? 1. What's the degree of this? 2. What's the overall degree? 2. There you have it. All right. Everybody happy with that? All right. Standard form. Everybody's going to number 8. I'm going to write it in standard form, and then you can tell me why it's written in standard form. Standard form is negative 7x to the 5th plus x to the 4th plus 4x cubed plus 1. Someone tell me why that's written in standard form. Not from smallest to biggest, but yeah, the exponents. Look at the exponents. The exponents go from the largest all the way to the smallest. All right, that's standard form. Largest exponent to smallest. Don't forget, the sign in front is the sign, right? So that says negative 7x to the 5th, negative 7x to the 5th, positive x to the 4th, positive x to the 4th, positive 4x cubed, positive 1. All right, hopefully that made a little sense to you. Now let's look at number 10. Writing that in standard form. Which one has the largest exponent? Right. So you write down negative x to the 8th plus 2x to the 7th. If I said, okay, tell me what the degree is, you would tell me the degree is 8. Is it a monomial, binomial, trinomial, polynomial? Binomial. It has 2 terms. All right, here we go. 12. Write it in descending order. So negative 4x to the 5th minus 2x to the 4th plus x. And then plus 3. This is called a polynomial. And the degree is what? Degree is what? 5. The degree was 5. All right. Anybody have any questions with that? What?
So when it's a whole number 3, then it's 1, and then when it's absolute, is it?
This is to the first power.
Alright, and 3.
This is x to the 0.
Oh,
All right, Eston, what's the matter? You good it? All right, now we're on to the important stuff. All right, the important part is now where we're adding and subtracting. Last week we did multiplying, dividing, and we did powers. All right, now today you're adding and subtracting. All of that last week was monomials. Today we're adding monomials and binomials and trinomials and polynomials. You can only add them if they're the same. All right, you can't add them unless they are exactly the same. All right, so if I'm looking at number 14, we always want to start out writing in standard form. That means we look for the largest exponent. What has the largest exponent? 4x squared. Is there anything I can combine with 4x squared? 6x does not go with 4x squared. You're adding x squareds. You're adding x squareds. Are there any other x squareds? No. So it's 4x squared. After x squared comes the what? X's. Is there anything I can combine with the x's? So then it's plus 6x. And now I'm looking for numbers. 9 minus 7 is what? Plus 2. That is your answer for number 14. Combining like terms. Everybody knows how to do this. Everybody take a quick look at 16. What happens to the x squareds? Nice. They cancel out. X squared, negative x squared, they cancel out. Now I'm looking at y squared and y squared. Come on now, someone who's thinking carefully and clearly. Y squared plus y squared is, everybody says y to the fourth. Everybody is what? Wrong. Again, the number in front, listen to me how I learned this. This is 1y squared plus 1y squared. What do I have in total? 2y squared. When you're adding, I never said add the exponents. When you multiply, you add exponents. When you add and subtract, the exponents stay the same. All right, come on now. Let's everybody take a look at 18. Two x squared. What am I going to combine with 2x squared? Wow, you are smart. 2x squared and negative 6x squared. How many does that give me?
-4x.
Negative 4x squared. Everybody's writing that down first. Next, I'm looking at 5xy minus, how many is that? 1xy gives me what?
4x.
Positive 4xy. And then 4y squared plus 2y squared is, say it, 6y squared, positive 6y squared. So if I was asking you, that final answer, is it a monomial, binomial, trinomial, or polynomial? Trinomial. What's the degree of this term? 2. What's the degree of this term? 2. What's the degree of this term? So the degree overall is 2. All right, what? Come on, I got lots of work.
Why is the because the exponent is supposed to be in front of that. So your next step, you took 5xy, but once you take
5xy minus 1xy.
yeah, don't you put the exponents first? So it'd be 4y to squared.
No, this is minus 1. What's 5 minus 1?
No, I get that. I'm saying, wouldn't you? That would be at the end because there's no exponents. You do greatest to small.
Well, actually, 2 to
That's the
1
same.
to 0. You with me?
Yeah.
All right, so don't worry about that. Okay.
All right.
I understand what you're asking me now. All right, now everybody put a star by number 20. What's the difference between 18 and 20?
There's a subtraction.
Subtraction. We're not adding. So we're going to change the subtraction to what? Addition by distributing a -1. We are going to distribute a -1. Now, we're smart enough, we don't have to put the -1 there, but what I would like you to notice is, look what I'm doing, guys. I'm going to change this to a plus and circle it. Change this to a plus. Change this to a plus. And change this to a what? Subtraction. I distributed the negative. When you distribute the negative, you change signs. So now combining terms. 8x squared combines with what?
X squared.
And how many do I have?
9x.
9x squared. Very nice and very easy. Now we're going to combine -4x and positive 2x, which is -2x. Now, come on.
-3 minus 5.
-3 minus 5 is what? -8. Monomial, binomial, trinomial, polynomial. What is that? Trinomial, what's the degree? 2. Good. Thank you for listening. All right, does everybody see a minus sign here?
Yep.
Change it to what?
Positive.
Change it to positive, and then I circle it. Positive, circle, negative, circle, positive, circle. I made lots of mistakes with positives and negatives. That's what I'm trying to show you. Change the signs. Come on now. How many x squareds do I end up with?
What do you mean?
How many x squareds?
Oh,
This right here.
5x.
Thank you. What?
5x squared.
5x squared. What's next?
4xy.
Plus 4xy.
7y squared. Plus 7.
Plus 7y squared. Perfect. Okay, now what I'm going to do is I'm going to pause just for about a minute. All right, what happens? Plus, circle, plus, circle, plus. All right, now I'm starting with 9x squared y squared. I can only add x, y squareds. So altogether that would be 17xy squared. Then what? Plus 7xy. Come on, guys. That's not too bad. That's not too bad. All right, here we go. Number 26. This is a what kind of trinomial? Trinomial. Everybody write that down. What's the degree of the first term?
4.
2. Thank you. What's the degree of the second term? 1. What's the degree of the third term? What's the, yes. So the final degree. Exactly. Thank you for listening. So 28 is called a
No, try.
monomial. It's one term. There is no addition or subtraction. So this is a monomial.
Oh, I thought you meant 6.
And what, in fact, would the degree be now? 1. Very nice. What?
I don't understand how that's 1.
The exponent is a 1.
Oh.
Okay, don't be fooled by 30. 30 is called a what? What can I do with 9 minus 3? 2a. Nine minus 3 today is 6, right? So what is this called now? Trinomial, and
2.
its degree is 2. Trinomial degree is 2. Anybody have any issues? What? Here's 8c right here, right?
Like you have 8C2.
Oh, it's not an 8c school. I don't know why. I'm going blind. Thank you. Good job, kiddo. 2c squared. All right, here we go. Let's just make sure we got enough done. All right, standard form. All right, 32 in standard form. Who's going to give it a shot? Go.
3x squared.
Good job.
Plus 5x.
Yep,
And then minus 6.
exactly. All right, exactly. Now, I'm not going to ask you about the leading coefficient, but the leading coefficient is obviously 3, right? The leading is the number in front. All right. All right, number 34. Go. We're doing in standard form, right? So largest exponent to smallest exponent. What has the largest exponent?
3x.
Right? 3x to the what? Yes, 3x to the third.
3x.
What kind of x squared? Negative x squared, then what? Good, then what? Yes, very good. That's it. Polynomial. All right, let's see if we can get number 36. James, what are we doing on 36? Yes, you are amazing. All right, and last and not least here for writing these in standard form. Go ahead. Jacob, are you doing it? Number 38, write it for me.
7x to the third plus x to the second minus x plus 64.
Amazing. That is correct. Anybody have any issues? All right, Emily, help me with 40 now. Combining terms. Look right here.
So that'd be 11.
Now. Combine the S's first.
Oh, okay, so, 14.
Yes. 14S. Very good.
Plus,
That's it, girl. That's all there is to it. That's it. 14S plus 9T. All right, Tosh, what do I need to do?
You need to distribute
Distribute, change that to a plus. The 2M becomes,
minus
and then the 6N.
comes a minus.
Yes, everybody looking at how we did that. So final answer.
9m plus or 9m minus 13 and
You're great. 9M minus 13N. All right, Forrest, what's up? What do I do?
You like distribute.
That's right. So this becomes a plus. What happens to the 2x squared? And what happens to the 5x? So tell me what's next.
So it would be 2x this, so do you combine,
Mm-hmm.
oh, okay, so, oh, yeah. Negative 1x the second,
Good.
and then minus 8x.
Yeah. That's it. That's all there is to it. Okay. London, help me. What's two to go together? Yes. And what is that? Yes. Good job, girl. And then what? Tell me again. Why are you saying that? Yes. You see what I'm saying? You just have to be careful, right? Just have to be careful. It's easy to make mistakes. All right. And 48. Let's go. Maggie, what do we got?
So you would combine the two,
Uh-huh.
and so then you get 10k squared minus 3k. Plus.
Wow. I don't know why I put an X. All right. I don't really care about 49 and 50. But listen to me, kiddos. I want everybody to try to do the odds now, okay? Except the last two. You with me? All right. Good job. I'm going to put this up now just in case.